I just had a coughing fit. Sorry about that. So the book has a couple of, well, a little rhyme to help us remember. So when the p-value is very low, the null must go. It means we reject the null hypothesis. When the p-value is high, the null must fly. We're going to stay with that. Thinking of what that graph looks like, I call it a graph, but really we're talking about our normal curve here. And probability, it could be in one tail or the other. We can just do it down here. So if this number, if this area under the curve is very low, it means there's not much chance that there's going to be our mean in there. So our mean is wrong. So that's why if the p-value is very low, the null must go. We have to come up with a new mean to make that true. If the p-value is very high, it means there's lots of space, right? It's a high number, high percentage of possibility that the mean is in here somewhere. And so that means that, yes, we are going to accept that this could be the mean. So we are accepting that null hypothesis. Let's just look at this down here, and we're going to simply look at the p-value and whether or not we're going to accept or reject the null or the null hypothesis. So we have a procedure that improves the chances of a boy being born. The results for the test of a single population proportion are shown right here. So we have it equal to 0.5, and our alternate is that it is greater than 0.5, the chances of the boy being born. This is our level of significance, and our p-value is 0.025. So we are going to compare these two numbers, right? Right there. We're going to compare our level of significance with our p-value. If our p-value is less than our alpha, our level of significance, then we're going to reject it. But this p-value is not less, okay? This p-value is more. Since the p-value is higher, that means we are not going to go with the alternate hypothesis. It is a do not reject our null hypothesis. We're going to stick with the null hypothesis because the p-value is higher than our significance level. So if you put up with my bad drawing again, looking at a couple of examples from the book. Here we have our normal curve, and this is 10. And we have our null hypothesis saying that our mean is 10. And our alternate saying our mean is less than 10. So that means this whole area, okay? So sorry. So I could erase that and start over again. Anyway, you get the idea. We're talking about a big area here, and that it is 9% actually if we look at this p-value. What kind of test is this? This is a one-tailed test because we're just down at one end and drawing a picture of it. You saw my lovely picture. Hopefully yours will be better if you can use a pencil and paper. And so this would be a do not reject situation. I have a pretty high percentage, 9%, that this is going to be one that I hang on to, that null hypothesis. Here we have 1 as our mean, and our null hypothesis is that the mean is less than or equal to 1. So this is 1 right here. And our alternate hypothesis is that it is greater than 1, this area here. And the p-value is 12%. What type of test is this? Again, this is a one-tailed test. This is on the right. And we would not reject. If this was the only information we had, we would not reject our null hypothesis in this particular case. We got some other little things. I think we're going to do this in the next video so that I can bring up the calculator with it as well. So just a few things on that, just about how we reject or not reject and how we make those decisions about the level of significance and the p-value. We're going to work on the calculator with this next group, so I will make a separate video on that so you can find it easier when you're going back to look. Thanks.